Acids and bases. What are they and how can we identify them? Acids are ionic compounds. They break apart in water and form hydrogen ions, H+. The strength of the acid depends on how many hydrogen ions are released. Strong acids release more than weak acids. So they dissolve in water, they release hydrogen ions. Acids are also highly reactive, corroding most metals. They conduct electricity. They have a sour taste and produce a stinging sensation on the skin, but neither of those last two should you attempt to test in a lab, just in case the acid is too powerful and too strong. Some common acids that you will have met at home. Citric acid, something you find in fruit. Ascorbic acid, also known as vitamin C, found in fruit and vegetables. Vinegar is a weak form of acetic acid or ethanoic acid. Carbonic acid is found in soft drinks. It's why the drinks are fizzy. And lactic acid is found in yogurt and cheese. Acids can be useful. So in food, they can be used to preserve because microbes, so bacteria and fungus, they don't really like to live in acidic environments. So you can preserve food for many months and years if you make the food sit in vinegar. Acids can be used with bases when you're cooking a cake because baking powder or self-raising flour, they contain a base called baking soda, which is sodium hydrogen carbonate. They also contain an acidic substance, and when you mix those two together with something moist, like an egg or some milk or water, they start to react and they give off carbon dioxide, which is a gas. The gas gets trapped in the cake mixture, and when you bake it, the cake rises and you get a nice light fluffy cake. You'll have heard about the damage acid can do to your teeth. When you eat, any food that remains between your teeth is a great tasty treat for bacteria in your mouth. They will feed on this, and part of their waste products will be acidic. And this acid will sit on your teeth and slowly dissolve them over many weeks and months and cause tooth decay. If you want to prevent tooth decay, you need to use toothpaste, because the toothpaste has abrasives in them which will help to scrape away any food particles from your teeth, and it'll also scrape away the hard material, which is a mixture of bacteria and acid and saliva that sticks to your teeth. That's the stuff called plaque. The toothpaste also contains a bit of soap or mild detergent, which helps to foam up and helps to neutralize acid in your mouth. Acid's very common in your stomach. The acid there is called hydrochloric acid, and it's very strong acid. It helps to produce the right conditions for digestion of your food. But it doesn't want to digest your stomach lining, so there's mucus on the lining of your stomach, and that acts as a barrier, and it keeps the acid away from the delicate muscle walls of your lining your stomach. So we've met a few common acids. Here are a few more. Aspirin is the common name for acetylsalicylic acid, and aspirin is used as a pain reliever. There are acids as preservatives in food, so sorbic acid is another example. We met vinegar before. You can get vitamin supplements like vitamin C. They are antioxidants. But there's also things like battery acid that you find in your car, herbicides to kill plants, and cleaning materials for cleaning metals. They're all acidic. Let's have a look at bases. Bases are the other side of the balancing act between acids and bases. A base is a substance that accepts hydrogen ions in a reaction, and the more that they accept, the stronger they are. An alkali is a soluble base. So an alkali has the same chemical reactions as a base. It just dissolves in water. And when it dissolves, it can release hydroxide ions, OH-. So you'll hear the words alkali and base used pretty much interchangeably at this level of chemistry. So bases absorb hydrogen ions, they neutralise the effects of an acid. So the acid gives off hydrogen ions, the base accepts them and absorbs them. Bases can be quite destructive in proteins. The proteins are found in your body. So you can denature proteins using a base. You can also tenderize proteins using a base before you put them on the Barbie. Bases have a bitter taste and they feel soapy, but just like with acids, we don't want to touch them or taste them in the lab or any of the strong ones you find in the cleaning cupboard at home. So examples of common bases, you will find them at home in the cleaning cupboard: soap, detergents, oven cleaners, drain unblockers. They're also in the baking cupboard, baking soda or sodium bicarbonate, and they can be found in the medicine cabinet too as antacids if you have an upset stomach. The chemical names of bases will include words such as hydroxide, oxide, carbonate or hydrogen carbonate. Those are clues that the chemical you're dealing with will act as a base. So some other examples here: caustic soda, you might see that in the name of a tin in the cupboard. Slaked lime is used in the garden to reduce the acidity in soil. There's some cleaning ammonia. Ammonia is a very soluble base. Then we've talked about baking soda. There's also washing sodas that you can buy in the washing aisle at the supermarket. They dissolve away the dirt and the oil on clothes, and then they can be washed away easily with water. Always remember safety when dealing with acids and bases, particularly in the school laboratory. They are corrosive. They will do damage to your skin, to your eyes, to your hair. So make sure you protect your clothing and your skin, and particularly your eyes. If you spill anything, rinse it off with water straight away and tell the teacher. And if you have a spill on a desk or on the floor, mop it up carefully without getting any on your hands. And tell the teacher before you leave the laboratory. The pH scale is very useful because you can measure how acidic or basic a liquid is. There are lots of ions in a solution that you might be using in the laboratory, but the pH is looking out for the hydrogen ions and the hydroxide ions. So there's a pH scale. You can see it runs from 0 to 14. pH 7, right in the middle there, is called neutral. pH 7 is neither acidic nor basic or alkaline. So the sorts of liquids you would see that be pH 7 would be things like pure water or salt water, like seawater. They would be pH 7. If something is an acid, it will have a pH between 0 and 6, and if it's an alkali or a base, it'll be between 8 and 14. So a strong acid will be down 0, 1, 2. A strong alkali will be up at the other end in the 12s, 13s, 14s. If something is a weak acid, it'll be closer to 7, so it'll be somewhere in the 5 or 6 range. And likewise, a weak alkali will be somewhere near neutral, maybe 8 or 9. The indicators that we use, there are several different types. An indicator is any chemical that changes colour when it's subjected to different pHs. So it indicates the pH of the solution. Universal indicator is great because it has a huge range of colours. It changes colour all the way from red through to purple, has oranges, greens and blues in different shades, and it gives you a really good indication of the different pH. Cabbage juice on the left-hand side, the picture at the bottom on the left, is similar in that it has a lovely range of colours. It's a natural indicator that we get from cabbages. Boil them up and you'll see that acids give you a very beautiful red colour through to alkalis which give a green colour. You may have seen that if you washed up any cabbage juice from steaming cabbage. It starts off red and you pop it into the soapy water and it goes green. Litmus paper and phenolphthalein have just one colour change. So they're one colour or another depending on whether they're in acids or alkalis, acids or bases. Litmus, you use the red paper to test for alkali and it'll go blue, and you use the blue paper to test for acids and it'll turn red. And phenolphthalein is my favourite indicator. I love that pink colour. In an acid, it's colourless completely, and in an alkali, it is a beautiful pink colour.